Okay, today we're going to learn how to find the derivative of exponential and logarithmic equations. So first off, we have to review what a derivative is. The official definition is that it's the limit of a series of tangent lines approaching a given point. And the formula representing this is this. The limit as h approaches to 0 as of the function x plus h minus the function of x all over h, and that's our basic definition. So first of all, I'm going to talk about how to solve for the derivative of an exponent of e. So what you have to do is first put it into the set equation to get the limit as h approaches 0 of the function e to the power of x plus h minus e to the power of x all over h. Now, we have to simplify this in order to solve for it. And to do so, we first can change it to be the limit as h approaches 0 of e to the power of x times e to the power of h minus e to the power of x all over h. And then we can factor out e to the power of x to have it to equal the limit of e to the power of x over 1 times the limit of e to the power of h minus 1 over h. So now we have this. Now that we have this, for the first portion, the limit as h approaches 0 of this equation is going to be equal to e to the power of x due to the fact h is a non-variable. Then we're left with this little portion right here. Now, nobody knows why, but trust me, the answer is 1. That equals 1. Nobody knows why. If they say they do, they don't. So it's going to be e to the power of x times 1, which is equal to e to the power of x. So thus, the derivative of e to the power of x is equal to itself. The first, second, third, etc. derivative is equal to itself. Now, moving on, what if it is an exponential equation, except it's not e? Well, then we have this as an example, y equals k being the constant to the power of x. Now, the first thing we can do is realize that the natural log and the exponent, base e, are opposites. So we can have this equation right here be equal to e to the power of the natural log of k to the power of x. And then we derive that to get dy dx equals e to x times the ln of k, which is the original problem with x brought down, times the derivative of x times the natural log of k. Now, in order to do so, we simply do the multiplicative rule, which is the first times the derivative of the second, 1 over k, I will explain why in a bit, plus the second multiplied by the derivative of the first. Which is 1. Now, since the derivative of the natural log of a constant is still a constant, so it's going to be 0, meaning we'll have e to the power of x times the natural log of k times the natural log of k. And since it's two exponents being multiplied, we can factor x out of that to have the natural log of k, all of this to the power of x times the natural log of k. And those two are opposites to finish up and equal k to the power of x times the natural log of k. And that right there is the derivative of a constant to the power. It will be equal to the constant to the power times the natural log of the constant. So after that, we'll find out what the opposite of an exponent is, which is the natural log, and we'll find out how to derive that. So in order to derive natural log of x, first you want to do is put it in the opposite terms, so that way it'll be e to the power of y equals x, and then derive it from there. So we have the derivative of e to the power of y equals the derivative of x, which means it's going to be e to the power of y dy dx, since it's in terms of y, equals the derivative of x, which is just 1. Then we solve for dy dx. So we have dy dx equals 1 over e to the power of y. And as originally stated in the problem, y is equal to the natural log of x. So this is equal to 1 over e to the natural log of x, which is equal to 1 over x. And that is what the derivative of a natural log is. But if it's not a natural log and instead is a different logarithm, then things get a little bit more complicated. In order to solve, let's say, y equals log base b of x, you have to realize the change of base theorem, which states that the log base b of something is going to be equal to log base a of the something over log base a of b, with a just being a common variable. So in this case, we're going to have a equaling to, a will equal e, so that way we'll have y equals the natural log of x over the natural log of b. And from here, we can derive it more easily, since it'll be equal to dy dx will equal the it'll be equal to the bottom ln of b times the derivative of the top 1 over x minus the top ln of x over the derivative of what the bottom is, which is a constant, which is 0, all over the ln of b squared. Now, since there's a natural log of b on top and bottom, we can take one out for each. And then we have 1 over x over natural log of b. And these two can be the same because can be put together due to the fact they're both being divided, to have the derivative of a logarithm of x equal 1 over x times the natural log of b. Now, I was thinking here will be an example in order to put everything into practice. We will find the derivative of y equals, I'm going to write a little bit smaller here, y equals the sine of x to the power of x. So, in order to start this, we're first going to find the natural log of each of them. To get the natural log of y equals the natural log of sine x to the power of x, we can bring the x down, x times the natural log of sine of x. And given this, we can derive from here. So first, to derive, we will find the derivative of the natural log of y, which is going to be 1 over y dy dx. Then we are going to derive this side to have x. We're going to have x times the derivative of this, which is 1 over sine of x, times the derivative of the inner part, which will be the cosine of x. All this plus the natural log of sine of x times 1, which is the derivative of x. From this point, we're going to solve for dy dx. So we have dy dx equals y times x times cosine over sine is cotangent of x plus the natural log of the sine of x. And as stated in the original problem again, y is equal to sine of x over x. So we can figure out that the derivative of the sine of x to the power of x will be equal to the sine of itself all multiplied by x cotangent of x plus natural log of sine of x. That's all I have for now. I'm out.